Question 2, Part A. Differentiate the following functions. Part 1, 3x squared plus 4 in brackets to the power of 5. We are differentiating a composite function, or a function of a function, and it's in the form y equals f of x in brackets to the power of n. Now the outer function is the power function, raising to a power of n, and the inner function is our function f of x. By the chain rule, the first derivative y dash is equal to the derivative of the outer function, so that's the derivative of the power function, so the n comes out to the front, here it is, and we reduce the original power by 1, so f of x is now to the power of n minus 1, and then we multiply by the inner function, so we multiply by the derivative of f of x, which is f dash of x. In this case, our f of x is 3x squared plus 4, and it's being raised to the power of 5. So by the chain rule, the first derivative y dash is equal to 5 times 3x squared plus 4 in brackets to the power of 4. So that's differentiating the power function. The 5 comes out to the front, and then we reduce the power by 1. And then we multiply by the derivative of the inner function, which is our f of x. The derivative of 3x squared plus 4 is 6x. So y dash is equal to 5 times 3x squared plus 4 in brackets to the power of 4 times 6x, which simplifies to 30x times 3x squared plus 4 in brackets to the power of 4. Part 2. X times sine of x plus 1. We are asked to differentiate an expression which involves a product of two functions of x, so the product rule will need to be used to find the first derivative. Let y equal u times v, where u and v are both functions of x. Then by the product rule, the first derivative y dash is equal to u dash v plus uv dash. Let y equal x times sine of x plus 1. Our u in this case will be x. Our u dash is the derivative of x, which is 1. Our v is sine of x plus 1. And by the chain rule, v dash is equal to cos of x plus 1. So applying the product rule, our first derivative y dash is equal to u dash times v, so 1 times sine of x plus 1, plus u times v dash, so plus x times cos of x plus 1. And that simplifies to sine of x plus 1 plus x times cos of x plus 1. Part 3. Tan x over x. We're differentiating a quotient where the numerator and the denominator are both functions of x. So we'll need to use the quotient rule to find the first derivative. Now let y equal u over v. So by the quotient rule, y dash is equal to u dash v minus uv dash over v squared. Now given y equals tan x over x, u is equal to tan x, u dash is equal to sec squared x, v is equal to x, and v dash is equal to 1. So putting that all together, the first derivative y dash is equal to x times sec squared x minus tan x times 1, which is just tan x, over x squared.